Alright, so now we're looking at divisibility tests. So we're going to look at divisibility tests for numbers 1 through 11. Okay, if something is divisible by 2, that means it's even. Okay, so example, if we had 302, this is even. So we know that 2 is a divisor. Okay, then we look at 3. So for 3, it's the sum of the digits. Okay, so we take the sum of the digits, and that's divisible by 3. Okay, so we divide the sum of digits by 3, and if that divides evenly, then the whole number is divisible by 3. So for example, if we were to look at 306, okay, 3 plus 0 plus 6 is 9. 9 divided by 3 is 3 remainder 0, so then it would be divisible by 3. For 4, it's the last 2 digits. So if something's divisible by 4, then the last 2 digits are divisible by 4. Okay? 4 would divide the last 2 digits. So for example, if we were to try again, like 306, 06 isn't divisible, but if this ended in an 8, and it was 308, 08 is divisible by 4, so the whole number would be divisible by 4. For it to be divisible by 5, the number has to end in a 5 or a 0, okay, or 0. If it's divisible by 6, that means it's divisible by 3 and 2, so that means the sum of the digits has to be divisible by 3, and it has to be even. So it has to be even, and sum of digits is divisible by 3. Okay, 7 has its own rule, but it's kind of complicated, so you're not going to be held accountable for that, so we're not going to worry about that one. For 8, if you have a really large number, if the last 3 digits are divisible by 8, the whole number is divisible by 8. So last 3 digits of the number are divisible by 8. Okay, and then if something is divisible by 9, it means that the sum of the digits of the number is divisible by 9. Okay, if something is divisible by 10, that means that the last digit is a 10. Or sorry, is a 0. And that's kind of a mix of the number ends in 5 or 0 and it's even, right? So that has to satisfy really 2 and 5 for 10. And then 11 is a really weird one. So with 11, what we do is we take a number and we break it up every other digit and take the sum of those 2 pieces, and then we divide it by, and we take the difference, and if that's divisible by 11, that's what we use. Okay, so what that means is that we take the sum of every other digit. That'll give you 2 numbers, because you have the first sum and the second sum, and then you take the difference of the sums, and then if that's divisible by 11, the number is divisible by 11. So we're going to do the example. I believe this is example 3 in your slides or in your notes, and what we're going to do is we're going to do all the divisibility tests on 162. Okay, so first we test 2. So is it a divisor? Okay, so first thing we're going to test is 2, and we say yes because it's even. Okay, we don't have to find what it is, we just want to know yes or no. Okay, then we test 3. So here we have to do the sum of the digits from up here. So we do 1 plus 6 plus 2. That gives us 7 plus 2, which is 9. 9 is divisible by 3. So then this number is divisible by 3. Okay, then we test 4. Last 2 digits have to be divisible by 4. So we go, okay, does 62, does that divide by 4? And the answer would be no, because we're going to have a remainder of 2. Okay, this would be 15 remainder 2, so not divisible by 4. Okay, we test 5. It does not end in a 0 or a 5, it ends in a 2, so not divisible. by 5, okay, because it ends in a 2. Then we test 6. The answer for 6 is yes, because it's even and the sum of the digits is divisible by 3. So yes, because both 2 and 3 divide 162. Okay. 7, again, we're not held accountable for that one, so that has a test, but it's more challenging, so we're not going to worry about that one. For 8, here we take the last 3 digits. This is a 3-digit number, so we have to do the whole thing. But our answer should be no, because up here, if it's not divisible by 4, it's not going to be divisible by 8. Okay? Because we're really just taking out another 2. So if not divisible by 4, eight won't be a divisor. And again, that's because 4 is a factor of 8. So if a factor doesn't work, then the number itself isn't going to work. So we ask ourselves 9. Okay, so when we did the sum of the digits up here, 1 plus 6 plus 2, we got 9. So that tells us that 9 is a divisor because 9 is divisible by itself. Okay, we test 10. It does not end in a 0, so the answer is no. Then we do 11. Again, this is the weird one. Okay, this is the really weird one. So when we do test 11, we're going to do the odd digits. So we do 1 plus 2, because we're doing every other. And then otherwise we just have 6. So 1 plus 2 gives us 3. So now we're going to take the difference between 6 and 3. Just using the bigger number first, we get 3. 3 is not divisible by 11, so the answer is no for that one. Okay, and in the slides there are more examples of each of these divisibility rules up here, so you can get those by reading the slides. But so what is a divisor? It would be 2, 3, 6, and 9 would be our divisors from our divisibility tests. Next, we're going to talk about prime factorization.